By the end of this lesson, you should be able to explain total internal reflection of light, define the critical angle C, relate the critical angle to the refractive index, n equals to 1 over sine C. You can see most of the rays bend as it leaves the glass block. Some of the rays don't leave the block. It bounces back at the glass air boundary. What do we call this light phenomenon? What happens to the refracted ray as the incident angle gets bigger? The refracted angle gets bigger. It moves closer to the glass boundary. What happens to the intensity of the refracted ray and the reflected ray as the incident angle gets bigger? The refracted ray gets weaker and the reflected ray gets stronger. More of the light ray is reflected than it is refracted. What would happen if the incident angle is increased further? Total internal reflection. When light travels from glass to air, refraction occurs. Some of the light is reflected, but most of the light is refracted. As the incident angle is increased, more of the light gets reflected. When the incident angle is very large, all the light is completely reflected at the glass air boundary. Will the same thing happen to a light ray moving across an air glass boundary? What happens to the refracted ray as incident angle gets bigger? The refracted ray also gets closer to the air boundary, but will never be close enough to be reflected completely. When a light ray with a big incident angle hits the glass air boundary, it doesn't get refracted, but totally reflected. This is called total internal reflection. Total, because 100% of the light is reflected. Internal, because it happens inside the glass. Can you identify the conditions for total internal reflection to occur? Light travels from a dense to less dense medium. For example, from glass to air. The incident angle is large. The critical angle is the incident angle when maximum refraction occurs. The refracted angle will be 90 degrees. For total internal reflection to occur, when light travels from a dense to less dense medium and the incident angle is larger than the critical angle, total internal reflection occurs. When a light ray exits a medium, it takes the same path it entered. We say light is reversible. Observe how we can relate the critical angle to the refractive index. If we can increase the angle in the medium to the critical angle, then the angle in the air, the refracted angle, is 90 degrees. Light is reversible, so we can use the refractive index. We find that the refractive index of a medium is the inverse sine of the critical angle. The refractive index, n, is the inverse of the sine of the critical angle, C.
Select a block by clicking on it. State whether the medium of the block is more or less dense than air. Then click on the ray box and drag it along the block. Observe whether total internal reflection will occur in that medium. If you think total internal reflection will occur, calculate the critical angle. Click on the Show Table button to check your answer.